15 years or so, what's happened is that those web pages now contain executable code. They contain Java or JavaScript or Python and things like that. And the browsers still innocently download the page and interpret it. Some of them are operating at fairly high privileges in the operating systems that they're embedded in. And the consequence of that is that you install various kinds of worms and viruses and the like. So Chrome is intended to be somewhat more resistant to that by isolating any executable into a kind of a sandbox. Again, it's no guarantee of perfection, but it is an attempt to move towards a much more suspicious, mutually suspicious environment. YouTube is another example of an application that Google supports. The latest information I have is that 23 hours of video per minute are being uploaded into YouTube. I have absolutely no idea who's watching all that stuff in it, but it's just pouring in. It's a very, very egalitarian, democratic, and popular way of expressing yourself. Here's another interesting example of technology. This is a story that was published in El País, in the Spanish newspaper, and I don't read Spanish very well, so I went to Google Translate and gave it the URL of the page, and it handed back the page with all the Spanish translated into English, laid out exactly the same way. Now, none of the translations are absolutely perfect, and we all remember the stories in the 1960s when the computer science people thought that the easiest way to do translation was to just put the dictionary in the computer and do word lookup. So we did that with a Russian English dictionary at Stanford. You know, we put in out of sight, out of mind, translated it into Russian, translated it back into English, and it came back invisible idiot. So, okay, we need work on this. The net is going to house an incredible number of devices, maybe more devices than there are people. Here are some examples of things that can already be found on the Internet, certainly things I didn't expect, like refrigerators and picture frames. The guy in the middle has an Internet-enabled surfboard. I've never met him. He's from the Netherlands. Now, all I can imagine, he was sitting on the water thinking, you know, gee, while I'm waiting for the next wave, if I had a laptop in my surfboard, I could be surfing the Internet. So he put a laptop in the surfboard, put a Wi-Fi service back at the rescue shack, and he sells this as a service. Here's an example of a sensor net. I'm really very proud of this. I have an IPv6 wireless network running 6LoWPAN, 802.15.4, that's sampling temperature, humidity, and light levels in all the rooms in the house every 5 minutes, and it stores it away in a server that I have in a rack in the basement. And at the end of the year, I know it sounds like something only a geek would do, but there really was something I intended was to have real data so that at the end of the year I could assess how well the heating, ventilation, and air conditioning system actually worked. So this is a very important part of my housing environment, especially because one of the rooms is the wine cellar. And so it's important to keep that down to below 60 degrees Fahrenheit and above 50 or 60% humidity to keep the corks from drying out. So it's alarmed, and if the temperature rises above 60 degrees, my mobile goes off with an SMS saying your wine is warming up. That actually happened a few weeks ago. I was away, and my mobile went off. I called my wife and said, please restart the cooling system. I had been thinking that because I can sense light levels, I could figure out if somebody went into the wine cellar when I wasn't there. But the problem is I can't tell whether any bottles left. So my next step is to put an RFID chip on each bottle. Unfortunately, one of my engineer friends, now there's a bug with that. They could go in and drink the wine and leave the bottle. So I have some more work to do, sensors in the cork, you know, things like that. All right, so I promised to get off into the cloud computing world. So what I'm not going to try to tell you what cloud computing is, or even I'm going to ask a whole bunch of questions because it is in the cloud computing environment that the NEAM systems are ultimately going to have to work. So here are the kinds of things that I think of when we talk about cloud collaboration, the interactions among clouds. Lots of different people are making clouds. Google makes a cloud and runs a very big one, multiple data centers all over the world. Microsoft does this. IBM does this on an enterprise basis. Amazon offers cloud services. They're not all the same, but they have the same general notion of aggregating huge amounts of computing and storage capacity and flexibly allocating it in order to carry out various applications and services. It's a very, very persuasive and attractive economic proposition because you put a lot of computers in one place. You can be more efficient about energy utilization. You have very efficient use of people time. And when it comes to software, one nice thing is when you upgrade the software in the cloud, everybody's software gets upgraded at the same time. So you don't have this very spotty problem of people upgrading software to new versions in spurts and in little islands, and then you run into interoperability problems. So cloud-like environments can sometimes be very helpful in terms of maintaining some kind of uniformity. The other interesting thing about data sharing is that if you put all the data into the cloud, then if 2, 3, 4, whatever number of people or institutions are sharing that data, there's never any question about what's the most up-to-date data. It's the data that's in the cloud, not the copy that's sitting in your laptop or your desktop. And that has been very advantageous for creating collaborative environments, particularly if it's a real-time involvement. In the Google Docs world, because updates are done in real time, in the cloud, you can actually have a group of people who are talking to each other and making edits to a document and actually seeing the edits happening in real time. And it actually accelerates either the rate at which you reach closure, or it accelerates the amount of argument that goes over the particular wordsmithing that you're trying to do. I found it very powerful, though, to be able to work in that fashion. Now, there are a lot of very interesting questions that show up when you start asking about how clouds interact with each other, because for the most part, they have not been designed to do that. So the first question, if you wanted to, if you had data in Cloud A and you wanted to move the data or copy the data to Cloud B, one question is, how do you say Cloud B? Most clouds don't even have the concept that there's another cloud. You know, all they know is that I'm the cloud, end of story. This is kind of like the Internet, before the Internet, in the 1970s. Lots of networks existed. Lots of computers could talk to each other through those networks using proprietary protocols like SNA and DECnet and so on. But if you wanted to move something from one net to another, you couldn't even say, move it to this other net, because you didn't know how to say that. There was no vocabulary for it. So clouds have this missing vocabulary problem. The second question is, how do you make reference to data that's in that cloud? And how do you make sure that the references are persistent? So I remind you that URLs in the Internet, as wonderful as they are not stable. A domain name is embedded in a URL, and if that domain name is deregistered or reassigned or anything else, all the references to that URL may no longer resolve properly. That's why URIs or URNs, Uniform Resource Names, are important, because they are not bound to domain names, but they still have to be resolved. And so there's this really fundamental stability of reference that requires stable resolution and long-term storage of that kind of resolution information. That's going to be true for all the various data sets that, to use an old word, that you have to deal with here. You're generating data all the time. A lot of it's archived. A lot of it has to be referenced over time, and we want to be able to get access to it and reference it on a reliable basis. There are questions about how you protect clouds from various forms of attack, how you, here's an access control problem that's really interesting. Let's suppose I've got data in Cloud A, and it actually is access controlled. So I have lists of authorized users who can either read or modify or do something with that data. And I decide that for a number of reasons I want to move that data to Cloud B, and let's pretend I can actually say that. But I also want to move the access control to Cloud B. So the question now is, well, what metadata do I have to move to Cloud B in order to reinstantiate correctly the access controls that were associated with the information in Cloud A? How do I say that? How do I even convey to Cloud B all the information that it needs, all the authorization data, all the identity information that it needs in order to reinstantiate the access controls? So we are, as hard as you have worked on the NEAM ideas for the data structures and the metadata about how to interpret this, the semantics and the syntax and everything else, as we start embedding that into cloud environments, we expand some of the challenges and the demands that are being made on the treatment of that data. Let's see. Well, there's a lot of other things in here. In fact, if we are going to talk about clouds exchanging information at all, the more general term that one might use is digital object. It's a nice generic phrase. The question is, what should a digital object be? What should a cloud expect when one arrives? How could it assemble one and send it in a way to another cloud that would be interpretable? And I think NEAM has a great deal to say about those concepts, but the details, of course, still have to be worked out in many respects. So an important thing about thinking about clouds and inter-cloud interaction is to create a set of use cases. These are just examples. They're just fanciful thoughts about things you might do. You might want to move the data from one cloud to another. You might want to be able to begin a computation in one cloud, and then if you run out of capacity, continue that computation or expand it in another cloud. But the implication is the two clouds have to share enough context in order for that to make sense. I want to be able to move things around and have access to the clouds in a portable way. I want things to be interoperable, the data in particular. You know, one question is what role NIST might play in all this. I don't know, maybe you can say, Donna, but does NIST have a current role in the NEAM activity?
Somewhat.
Somewhat, okay. So one of the things, I sit on the visitors committee at NIST, so I have a little bit of insight into the scope of their responsibility. One of the things that they do is called documentary standards. And and they have a coordinating role for this, not a defining one, but a coordinating role. It could very well be that NIST could help with the introduction of NEAM into the general federal environment if a documentary standard were part of their activity. Of course, I'm overloading my friend Sita Furlani, who runs the Information Technology Lab, who's already got the problem of healthcare records and smart grid standards and so on. So there's a whole lot of possibility that clouds introduce and that NEAM can inform. There's a group called cloudstandards.org, and they have a wiki, and to the extent that you are interested in exploring things, you might want to go have a look at the wiki, where they're trying to accumulate information about people who are interested in and are pursuing the implementation of clouds. There are other organizations like Cloud Security Alliance and Storage Networking Industry Association. There's a very long list of people who are interested in cloud computing, just like there's a very long list of people who are interested in database exchange. You represent a fraction of that interested community, and I can tell you it expands rapidly outward into the private sector, which, by the way, raises another thought, which is to what extent can NEAM be conveyed into the private sector, because so much of what goes on in the federal government is dependent on information coming from or going to the private sector. So establishing a foothold in the mind share in the private sector for NEAM concepts and specifics would be a very, very powerful step in the right direction. Filling up a data center, what do you do with a big data center? Well, one thing we do with it is on-demand applications, where somebody comes along and says, I need to do X, and we say, fine, we'll instantiate X for you, and we'll run that application. One thing that we've discovered at Google is that conventional database technology does not scale necessarily very well. And for the kinds of databases that we deal with, where we're talking about tens of billions or hundreds of billions of things, we've had to design and build new kinds of technology like Bigtable as a way of allowing a database to be scattered across a very, very large number of processors and memory elements. And then to make things even more hairy, we have multiple data centers, and we are determined that the data that goes into Bigtable is replicable across multiple data centers and is stable. The reason we do that is that the data center goes away. You don't want to not get your Gmail. You don't want to not get your documents. You don't want to not have an application run. You need for this stuff to be highly resilient. So we're very aware of that. Certainly the private sector expects that of us. And as Google begins to work with the federal government, we find that you're no different than everybody else. You expect things to work whenever you want them to work. You expect your data to be up to date, and you expect it to be accessible.